So remember when we have geometry problems, like you always want to like draw a diagram first. So in this question, we have points A, B, C, D, E, and F that lie in that order on AF, dividing it into 5 segments, each of length 1. So we have like, let's try to draw this diagram, right? So A through F. So we have A, B, C, D, E, F. And we're given that it divides it into 5 segments of length 1. So 1, 1, 1, 1, 1. Those all have length 1. And then we're given that G is a point not on line AF. So let's say G is like somewhere here, maybe. And we know that point H lies on GD and point J lies on GF. So, and we're given that the line segments HC, AJE, and AG are parallel. So let's first draw an AG. So we know that H lies somewhere on GD. So let's say H lies somewhere here. And we know that HC has to be parallel to AG. So these two are parallel. And we know that J lies on GF, so that JE is parallel to AG. So like all 3 of these lines are like parallel. They're like parallel. So you can draw arrows to like indicate that like they're parallel. And we want to find what is like the ratio of HC to JE. So the idea for this question is like whenever you have parallel lines, when you have a bunch of parallel lines, like in this case, we have a lot of parallel lines. And it's always important that parallel lines like create similar triangles. Like probably the most like common place you'll see similar triangles is when you have parallel lines. So since we're given so many parallel lines here, that would motivate us to think about using similar triangles. So the idea is we can take a look at this red triangle like HCD, and then we can take a look at this like blue triangle, right? Like GAD. And we know the red triangle has to be similar to the blue triangle. So we have that like the ratio of corresponding sides has to be equal. So we have that like for example, this green length divided by this green length has to equal like this, like, I don't know, this yellow length divided by this yellow length by like similar triangles. So by similar triangles, we have that HC divided by AG has to equal 1/3, right? By similar triangles, because we know HCD is similar to triangle GAD. So HC over AG has to equal 1/3. And then we can apply a similar idea by looking at this like this green triangle here. We know that has to be similar to this blue triangle, like the big blue triangle, like GAF. So triangle JEF has to be similar to triangle GAF. So again, by similar triangles, the ratio of corresponding sides has to be equal. So JE over AG has to equal 1/5, right? So JE over AG has to equal 1/5. And then we want to find what is the ratio HC over JE. So we want to find HC over JE. So it's just to do that, we can just like divide these 2 equations, like divide both of them. So if you're to divide these 2 equations, here, like the AGs would cancel. And then on the other side, you would have like, if you flip the fractions, you get like 5/3. So you get HC over JE is equal to 5/3. And then if you were to look back at your answer choices, that would be like choice D. That would be like the right answer. So I think like the general idea was like parallel lines. You should always like see parallel lines as, creating similar triangles. So your first like thought in this case should have been like similar triangles, like immediately after they gave you the parallel lines. And another reason why you might think of using similar triangles is because they ask for HC over JE, and that represents like a length ratio. And whenever a question asks for like a length ratio, like a lot of the time, similar triangles could also be helpful in those cases. And yeah, I don't think this question was terribly complicated. If you just noticed a few pairs of similar triangles, and if you did that, like the questions really weren't like, and the question really wasn't that bad by just applying similar triangles like 2 times.